So I gave you this question at the end of the last video. And what is the probability of F complement? First, remember the principle. A probability of an event is the sum of probabilities for the outcomes included in that event. So you have to first tell which outcomes are included in this event, F complement. First, event F includes these two outcomes. So F complement includes the others, these guys. Or in words, male. Male, these two types of people are male. And then probability of this event is sum of these two numbers, 19.89 plus 29 plus 29.59. So the answer is about 49.48%. That's how you calculate probability in general. Alternatively, you may use the complement rule when you calculate the probability of a complement event. So think about this. For any given event A, there are only two possible cases. First, A happens. Second, A does not happen. So no matter what experiment you do or no matter what event you consider, it's clear it happens or not. It's binary, right? And the event that A does not happen is equivalent to the event that A complement happens. So by definition, we defined A complement as the event that A does not happen. So when I say A does not happen, it means A complement happens, right? So because there are only two cases, there are some of the probably if you add these two probabilities, it should be always 100%, right? If A happens with 90%, A does not happen with 10%, right? The sum has to be always 100%, and then directly it implies probability of A complement equals to 100% minus probability of A. It's so when I write it as a mathematical equation, it it does not look that obvious, but when I say this, when I say it in casual words, it's obvious. It's just straightforward. So probability that A does not happen is 100% minus the probability A happens. So we call this the complement rule, but it's too easy. This is not a rule. Just or if you cannot understand this or if you do not want to memorize this, you may just use the general principle. This is more general principle that applies to everywhere. So um, I'm just telling you to give you a formula in the from the textbook. Okay, we learned an operation called complement. When you have an event, you can manipulate the event to a complement event. And now we will consider another manipulation method. It is called the union. So now think about a new event defined as female or having unhealthy insurance. You are interested in female or having unhealthy insurance. It means at least one of F or H happens. One of them happens. So it could be only female, or it could be having unhealthy insurance, or it does not matter if two are satisfied at the same time. So we call this event, this new event, as the union of F and H. So you have two events, and you are interested in all the cases where one of them happens. So it only rules out when both fails. Both fail. So mathematical notation is U-shaped sign. So we call this F cup H. It's often it's called as cup because it looks like a cup and also it looks like U. So you call this cup. And on the probability table, distribution table, you can mark the event in this way. So first, F, female includes these two outcomes, and health insurance includes these two outcomes, and their union includes all the outcomes that was included in either of them. So there are three outcomes included in the union. So these colored outcomes are included, the outcomes included in the union, and we define them. We defined a new event using two basic events. Then, what is the probability? What is their probability? Uh, you may pause. You may pause the video now and try this question. I will continue in a second. So I already told you there are three outcomes included in the union. So 13.8 and 36.72 and 29.59 are included in the union in the union event, like F cup H. So the probability of F cup H is sum of these three numbers, 13, 36, 29. If you sum them, you will get the answer is 80.11%. So that's how you calculate the union probability of union, and nothing special. I'm applying the general principle. And similarly, we can think about a new event connected by and. Previously, two events were connected by or, but in this case, we are connecting them by and. So the event that when you choose a random person, you are interested in the event that the person is female and has an health insurance. So two things have to happen at the same time. That's the definition of this event. So both F and H happen together at the same time. Such an event is called the intersection of F and H. So when F and H happen at the same time, that event is called intersection. Two events happened together. It is denoted as F inverse UH. The inverse U sign is called cap. So we say this is F cap H. F cap H is how we read it usually. And on the table, among these four outcomes, the intersection includes only one outcome, because female is these two outcomes, and health insurance include H includes these two outcomes, and we only take the outcome that is included in both events, female health insurance. So only 36.72 is included in both. So this is the probability. I already gave you the answer, so should be easy. So the answer is A. There is nothing much to say. Already I explained, because there is only one outcome included in this event, so there is nothing to think about, nothing more to talk about. So we learned three operations, three manipulations: complement, union, and intersection. These three are the most common ways to manipulate events, and combining these will make up a lot of and very complicated new events. So almost any event can be defined by these three notations. So, and notation itself is also important. Maybe you may have learned those notations in set theory, mathematical set theory, and we are using the same set theory because event itself is a set. As I said, event is a set of outcomes. So uh, the probability theory borrows the set theory notation to manipulate the event. And like for example, think about this event. I defined a new event using intersection and complement. Can you calculate this probability? I will stop the video here and uh, I want you to, I'll have you try this question more seriously. It may be a little bit difficult to some of you, so please try this.